Hello everyone, I am Miss Castanares.
I am Princess Joy Lastimozo.
And I am Benice Angela Aperong.
We are the reporters for today.
So, good morning everyone, and today we're going to discuss about Chapter 8 with regards to the linear programming applications. And we have here our objectives. Our objectives is to model a wide variety of medium to large linear problems. And for the next one is to understand the major application areas including marketing, production, labor scheduling, fuel blending, transportation, and finance. And for the third objective today is for us to gain experience in solving the linear programming problems with the QM for Windows or the Excel Solver software. We also have here our chapter outline composing of 8.1, the introduction. Next will be the marketing applications. Next will be the manufacturing applications, followed by the employee scheduling applications, and then with the financial applications. Right after that will be the ingredient blending applications, and for our last outline, we will have the transportation applications. Okay, so here in the introduction, we know that it is beneficial to understand or how to create and solve small linear programming issues using graphical method of linear programming, of course, taught on the previous chapter by the previous reporter. And now in this chapter, its objective is to take things further and to demonstrate how the linear programming may be used to simulate a huge variety of real-world issues in general. And this could be accomplished through the presentation of examples of models in the fields of marketing research, in the fields of media selection, production mix, labor scheduling, production scheduling, shipping and transportation for the ingredient mix, and the financial portfolio selection, among other topics. So we should know that this linear programming tool is used in business and industry for a variety of tasks, such as production planning, transportation and routing, and many sorts of scheduling. And among all its applications, we have here, the first one is in marketing application. Under the marketing application, we have two. The first one will be media selection, and the second one is the marketing research. But we'll now only focus to media selection. Here in media selection, the linear programming can be used to solve challenges involving media choices from two different angles. So we have to look forward to our two either objectives, which are to maximize the audience exposure and minimize the advertising cost. So as a decision aid in advertising business, the linear programming models have been employed to select a successful mix for a number of years. So it has been used long time ago. It's been used now already. And some companies use this strategy when allocating a fixed or limited budget across numerous media, which may include the very common types of media, which actually we're still using for today is television, and then radio spots, newspaper ads, magazine advertisements, and other forms of marketing communication. And in other application, the goal is to maximize its audience exposure, as what I have mentioned earlier. And of course, it will also vary in different terms. So, depende po ito. Kasi it depends on the circumstances. It depends on the contract requirements. And it also depends on the limited media availability. Also, it depends, of course, to the policy of the company. If ever they want to impose restrictions on the permissible media mix. So that's how it may vary. And now let me give you another good example, whereas the linear programming is used in media selection. So we have here the situation regarding the Win Big Gambling Club. So here we have we have here the things which is required when solving or maximizing its total reach of audience. Yun yung objective niya kasi dito. And before we achieve those, here are the things needed to be done or needed to be complied. The Winbig Gambling Club promotes gambling junkets to the Bahamas. And it has $8,000 per week to spend on advertising. And its goal, as I have said earlier, its objective or its goal is to reach the largest possible high potential audience. And the media types and audience figures are shown in the following table on the next slide. And it needs to place at least 5 radio spots per week. I mean, the advertisement needs to place at least 5 radio spots per week. And no more than $1,800 can be spent on radio advertising. So we have here in formulation the representation of different media. From X sub 1 to X sub 4, X sub 1 is the number of 1-minute TV spots where the advertisement will appear, and X sub 2 is where the newspaper ad or the advertisement will appear in the newspaper ad, and the X sub 3 and X sub 4 for the 2 different radio spots. And of course, its objective is to maximize the audience coverage, which is equal to the sum of the audience reach per media corresponding to the different media where it should appear. So we have here the 5,000 times X sub 1 plus 8,500 times X sub 2 plus 2,400 times X sub 3 and then the 2,800 X sub 4. So these will all be explained on the next video that will be shown, a tutorial video using our Excel solver. And then we have here, of course, our constraint. These are subject to or constraint by which is the constraint is where our restrictions or these things are limited to. So subject to ganon. And then for the next slide, here is our Excel solution. Dito, ipakita niya na solve niya na, pero I'm going to show a video to you, which is a tutorial video showing how did it arrive to this answer. So I hope you'll focus on your screen and listen so you could appreciate and you could actually know how to use the Excel solver software because it helps a lot. Okay, let's play the video.
So we're using a solver in Excel to solve the Win Big Gambling Club problem. Basically, we have 4 different choices of medium for which to advertise, which are the TV spots, newspaper ads, primetime radio spots, and the afternoon radio spots. We also have constraints. So given these constraints, cost, and the budget, what we want to know is how many of each type of spot we should run to maximize the audience that we're going to reach. The first thing we're going to start by filling in is how many people we reach with every TV spots, newspaper ads, and within the 2 radio spots. Now what we're going to do is write the formula of the objective function. What we want to know is, given that we run a certain number of TV spots, and each TV spot is going to give us an audience of 5,000 people, plus however many newspaper ad we run multiplied by 8,500 people, plus the number of primetime spots we run times 2,400 people, and then the number of afternoon spots times 2,800 people. Okay, so the way we're going to write this formula is with a sum product and take this range and say we want to multiply these items by these items. So it's going to be from cell B6 through E6 and from cell B7 through E7, but by making the B6 through E6 as an absolute value by adding $sign into it. And now we're going to copy this formula for all of the other constraints. We're going to copy this and paste it here. And then the next thing we're going to do is to write down our constraints. We have been told that the number of maximum TV ad that we should run in a week is 12. So why did we fill that in first? And for this to be less than or equal to 12, so taking the value of whatever is in B6, wanting that to be less than 12, we'll write that as putting a surrogate here. Well, a surrogate is a function that approximates another function. For example, to search for a point that minimizes an object function, simply evaluate its surrogate on thousands of points and then take the best value as an approximation to the minimizer of the objective function. And we're gonna put number 1 here. So you'll notice in its formula that the number of TV spots multiplied by 1 added to the number of newspaper ad that we run multiplied by none. Same goes with the next two medium, and this will give us the number of TV spots has to be less than or equal to 12. And for the maximum newspaper ads, we've been told that it is 5. The maximum number of primetime radio spots is 25. And the maximum number of afternoon radio spots is 20. And now we're going to deal with the budget constraint. And it has to do with how much money we have to spend. So we have to spend less than or equal to $8,000. It's $8,000. And we're not going to use 1 anymore in using this constraint, because now we're talking about how much are we spending. And it costs $800 to run a TV spot. So we take the number of TV spots we're going to run multiplied by $800 per ad plus how many newspaper ads we're going to run times the price of the newspaper ad, and so on. So the price of the newspaper ads is $925, while in primetime radio spot is $290. Also given in the afternoon radio spot is $380. We've also given a constraint on the amount of money that we can spend on radio ads, and it has to be less than or equal to $1,800. So again, as we are talking about the cost, the amount of money for spending on radio ads will also be $290 and $380 respectively. Okay, so notice that we put all of our less than constraint all together. And our last constraint is a greater than constraint. Here we've given a minimum of radio spots we should have in a week. And that is at least 5 radio spots. It's 5 or more for what it means. So talking back about the number of radio spots, we then again want to use the value of 1 multiplied by the number of primetime spots plus 1 times the number of afternoon spots to be greater than or equal to 5. So now as we complete our data, we are ready to use the solver. You have to go to the data tab, and then click the solver. You have to click the solver, and then you have to add all of this needed information. The objective function is in cell F7. So it has to be the cell F7 because that's the number of people that will be reaching, wanting it to be maximized. So the changing variables are from the cell B6 through E6. Okay, so now after that, we're going to input our set of constraints, keeping all together the less than constraints and then the greater than constraint. Because this way, in separating those, it allows us to enter this constraint as a block and not adding it individually. Okay, it's time to click the add. Click the add, and then you highlight the cell that has less than constraint. Okay, we have to highlight the cell that has less than constraint, and you want to set a constraint to the value of H9 through H14. Okay, click add again, and then now let's add another greater than constraint. Let's add a greater than constraint following the same input process. But of course, you could add more constraint if given any. But here, because this is our last constraint, we will press OK. Okay, let's have to press OK and then click here the make the unconstrained variable non-negative. And right after that, we have to solve this. Click the solve and then this will show you the results. Okay, these are the results that being solved by the Excel solver software itself. But these values could be rounded off if desired of making it a whole number. By that, you have to add another constraint and put it on integer. Okay, just have to add another constraint here. And you have to put it into integer because it means that a fractional value is not an option here and will result only to whole numbers. And this whole numbers will be resulting to a more accurate result. Okay, now after we put the integer, it shows whole numbers as its value.
Okay, for the second application for the marketing is, we have here the marketing research. So it's the linear programming has also been applied for the marketing research and for the area of consumers research. And marketing research is a scientific process that commercial organizations use to acquire information and determine the requirements and wants of the customers, as well as the most effective methods of meeting those needs and wants while maintaining the long-term profitability. The objectives are to provide the business organizations with the ability to fine-tune the marketing mix in order to better address consumer requirements and expectations while maintaining a balanced supply of products in response to the customer's demands. And the appropriate decisions may be made at the strategic, tactical, and operational levels by the business organization management. With the help, of course, of the descriptive, diagnostic, and predictive research at the strategic and operational levels using the right market research information. And it is possible for an organization to benefit from decision making based on the needs and requirements of the target market if the management uses or optimizes the linear programming model. So let me give you a real life example of it. So here is a management sciences associate, which is a marketing research firm. And here are the things or the requirements needed to be done or to achieve in order to solve for its missing piece. The MSA determines that it must fulfill several requirements in order to draw statistically valid conclusions. So in order for it to be valid, this should be followed. The survey should at least be 2,300 US households. And that the survey should be at least 1,000 households whose heads are 30 years of age or younger. And the survey should at least be 600 households whose heads are between 31 and 50 years of age. And to ensure that at least 15% of those surveyed live in a state that borders on Mexico. And another one is that to ensure that no more than 20% of those surveyed are 51 years of age or over lived in a state to border on Mexico. So here shows the table. The table shows two different regions, which is bordering and not bordering in Mexico, and of course the bracketing of age to the specific surveys. In the specific range of age, it has of course different costs. So iba-iba yung magagastos sa iba't ibang survey na gaganapin. Here, the MSA's goal is to meet the sampling requirements at the least possible cost. So here we have to minimize our costs, of course. And the decision variables are present. Decision variables represent from x sub 1 up to x sub 6, representing the number of ages in different regions. Different ages range where they belong, and of course if where they belong to any of those two regions. So just read on this. So written on the screen, is the representations of variables. Of course, needed to be input. I needed for the data on how to solve it on the Excel. And here our objective is to minimize total interview cost. Is what I have said, and it is the total cost per survey in a specific number of ages and regions where they belong. Represented by 7.50 x sub 1 plus 6.80 times x sub 2 up to the 6.10 x sub 6, and it has this specific constraints also. So given na dito yung mga constraints. And then for its Excel solution it's here, and the same process lang po siya ng pag-solve just as how we solved for the media selection. So if you've watched the tutorial and then you've learned something from it, it is also that easy to solve na lang this marketing research. So ganun lang siya kadali kasi ang data dapat kailangan mo lang naman yung data niya, the constraint, ito, restrictions, variables, solutions, and of course its objectives, and all you have to do is to input those. And now we are down to our second application, which is in manufacturing applications. We also have two items under the manufacturing application, which are the first is the production mix and the production scheduling. First, we are going to discuss the production mix. So, the total set of products or services offered by a company is referred to as the product mix, also known as the product assortment or the product portfolio. It is made up of product lines which are related things that consumers tend to use together or think are similar to one another. And in terms of products or services, a fertile field for the application of linear programming is the process of determining the appropriate mix of products to be manufactured. So managing a company's operation means dealing with a wide range of constraints, from financial considerations to sales, to demands, and to the material contracts, to union labor and demands. And its major objective is to earn the greatest amount of profit possible. So given here an example of the Fifth Avenue Industries. So we have here a situation, which is it has the four varieties of ties. So let's talk about ties this time. One expensive all silk, one is all polyester, and two are combinations of a polyester and the cotton blends. Here in the table, it shows the availability of the three materials used in the product process. We have silk, polyester, and cotton. And we have here the cost per yard. And of course, the material available per month. Here we have also the different variables. The firm has contracts with several major department stores chain to supply ties. And the contract requires a minimum number of ties, but of course, maybe it could increase. It depends on the demand. And the Fifth Avenue's goal is to maximize monthly profit given the following decision variables. So here are the variables. X sub 1 to X sub 4. For X sub 1, you have the number of silk ties produced per month. X sub 2 is the number of all polyester ties. X sub 3 is the number of blend 1 polyester cotton ties. And X sub 4 for the number of blend 2 silk cotton ties. Here are the datas of the Fifth Avenue. Of course, composing of the selling price per tie, the monthly contract minimum, kasi nga, di ba, nag-set sila ng contract sa mga retailers nila. And monthly demand. Of course, kasi iba-iba yung demand per month ng mga ties. So, we have here the data. And the material required per yards. So, it's cost din sa material na required kasi iba-iba din naman. And for the material requirements is if it is 100% silk, if it's 50% polyester, 100% polyester, or 100% cotton, 50% cotton. So, here it is being put. And of course, for us to solve for the objective of this Fifth Avenue industry, we have to also solve for the profit for each tie. So, per tie, given in the table, on the table number 2, on the last column will be $16, $8, $8, and $8. So, showing here the complete model kasi yung objective nga nito is to maximize the profit. So, it represents or it is equal to the sum of the profit per tie multiplied by the or corresponding to the different variables stated kanina, yung x sub 1, x sub 2, x sub 3 to x sub 4. So, may mga representations din sila which are the numbers of polyester tie, numbers of silk, numbers of cotton tie, blends, ganon, the x sub 1 to x sub 4. And then, of course, di mawawala yung constraints, which is importante din. Here, it is shown on this model. And here is its Excel solution. So, ganun lang din guys, you have to input the data and then the Excel will solve this for you. Kung ilan yung total profit mo. So, the result here is actually 412,028.88. So, that's a good result. Okay, moving on to the second manufacturing application. We have the production scheduling. In most factories, establishing a low-cost production schedule over a period of weeks or months is challenging and critical management risk. A variety of elements must be taken into consideration by the production manager, including labor capacity, inventory, and storage costs, space limits, and dami, product demand, and worker relations. Given that most businesses manufacture more than one product. Yes, yung mga businesses kasi they manufacture more than one product. And the scheduling procedure is frequently fairly complicated. For the most part, the problem is analogous to the product mix model for each period of the future. The goal is either to maximize the profit or to reduce the overall cost of the carrying out of that task, including the production and inventory. So that will be discussed sa example mamaya. And as much as possible, due to the fact that the production scheduling is a problem that needs to be solved on a regular basis, the linear programming is capable of providing a solution. When the target function and restrictions for a firm have been defined, the inputs may be readily altered each month to produce updated timetable for the organization. So, here sales forecasts are generated to evaluate demands in order to calculate how much of each type of product to manufacture at the beginning of the process. There are frequently a number of different production facilities where the products can be created, and the proper ingredients must be present in the production facility in order to the facility to generate the items assigned to it, both for procuring and delivering components to appropriate facilities as well as for the transporting of the final goods to the retailers. Transportation costs must be taken into consideration. To account for deviations from a master plan, the linear program that monitors production planning and scheduling must be updated on a regular basis. It could be daily or twice. It could be daily or once a day, ganun, or twice a day to ensure that items remain up to the current. So I'll give you an example. Example here is the Greenberg Motors Incorporated, which manufactures two different models of motors, which are the GM38 and the GM3B. And the Drexels are the 3 times a year for 4 months at a time. So we have here 4 months from January, February, March to April. So that's 4 months. And yung demand, of course, sa sinabi ko kanina nga, then every month, di naman talaga naging constant yung demand because it varies. And the Greenberg wants to develop its production plan for the next 4 months. So we're going to focus for the next 4 months of their contract. Here, we have to calculate for the cost of production. So unahin muna natin yung production. Of course, yung production should consider these following factors. The desirability of producing the same number of motors each month to simplify the planning and the scheduling. Second one is the necessity to keep inventory carrying costs down. And the warehouse limitations. It's no layoff policy, and for the linear programming is a useful tool for creating a minimum total cost schedule that resolves conflicts between the factors. We have here variables representing the number of models. A sub I for the number of model of the GM3A, which is the first motor, and the I actually represents for the number of month. And for the BI, for the second model, the number of model GM3B motors produced in 1 month. Here, iba-iba yung cost ng model per month. Okay, it costs, yung GM3A kasi, nagko-cost siya ng $20. And para mag-produce ka ng, to produce the first model, the GM3A, you'll be needing $20. And for the another model, the GM3B, you'll be needing $15. And they both increase, tandaan, both increased by 10% on March 1. Thus, so ito yung, function, ito yung equation niya. The cost of production is the total of the sum of the cost to produce per model. Pero, na-notice niyo nag-change yung amount niya into the third term. Which is kasi, the third term is the third month, which is the March. So, disregard natin na hindi natin kukunan ng 10% yung from January up to February since yung pag-increase ng 10%, nag-start lang siya sa March. So, hanggang April na yon. Nag-increase siya ng 10%. So, the other one will also increase in 10%. I mean, the second model. From 15, naging 16.50 kasi nga may 10% tayong dinagdag doon. And here is, ang kailangan naman natin i-solve is the inventory. Kuha na ng equation or ng function. So here is the variable, the IA sub I, which means the units of GM3 left in inventory at the end of the month. And for the IB sub I is also the second, representing the second unit of motor. Okay, meron din tayong different costs per inventory dito, per model, which is yung GM3A, yung first model costs $0.36 per month. While the second model, the GM3B, costs $0.26 per unit per month. And the monthly ending inventory levels are used for the average inventory level. So here is its function for the inventory, shown in this slide. First lang, gisunod lang din yung conditions and gimit lang siya. Okay, combining those functions will be forming our objective, which is to minimize our total cost. So, yun lang. Yung two objectives ng inventory and production is i-combine para makasolve tayo ng para ma-minimize natin yung total cost natin. So, that's how we solve for that. And mamaya sa Excel, and maybe you want to try na i-input itong data na ito for you to solve. And showing here the end of the month inventory, how to be calculated. Okay, inventory at the end of the last month plus the current month's production less than the inventory of the end of the month is equal to sales ng Drexel ngayong month. Dito, may changes sa demand. Greenberg is starting a new 4-month production cycle with a change in design. Specification to the left, no old motors in stock on January. So, January na naman yung pakikialaman na natin dito. Since yung demand ng January is from two different models is 800 to 1,000, we're going to rewrite it as A sub 1 less than the inventory na A sub 1 is equals to 800, and then for the next model is the B sub 1 less than the B sub 1 equal to 1,000. Of course, for the proceeding math, meron din tayong constraint doon, which is given here. Ayan. And the other constraint for the ending inventory ng April is A sub 4 is equal to 450, and for the second model, the B sub 4 is 300. Ayan. Mga mahahalagang informations for our solving to the Excel. And hindi lang yon ang dapat gina-consider, because we have to consider for our labor hours, and of course, gaya ng sinabi kanina is yung warehouse space. And no workers is ever laid off, so the Greenberg has a base employment of level of 2,200 labor hours per month. And by adding the temporary workers, yung available labor hours can be increased to 2,560 hours per month. And each GM3A, the first model requires 1.3 labor hours, and each GM3B second model requires 0.9 hours. So here is its constraints on written below. So medyo medyo complex siya kasi marami siyang constraint na hinahanap. And here is its Excel solution. So makikita niyo na tatlo yung constraints tatlong groups ng constraint yung gi-provide. And here is its solution, or here is its answers. Okay, for the January units produced here, for the GM3A is 1,277, and so on and so forth. And of course, yung units din ng GM3B and the January is 1,000, so on and so forth. And yung inventory, ito din yung result. And of course, to the labor hours required from January to April, nag-vary din. So, iba-iba yung result per month, since walang constant dito. And for the total cost for this 4-month period is $169,949.90. And actually, yung complete model, meron 16 variables, and it composed of 22 constraints also. So, masyadong marami. So, that's how complicated it should, that's how complicated it is. Pero, linear programming could make it easier naman, kasi you just have to identify your data, so you just have to input your data, and then, ayun na, Excel solver will do it for you. And for the next topic, we'll have another reporter. Thank you.
Good morning, everyone. The next topic is about the employee scheduling applications. Here we will learn about these applications in the real world and know how to utilize it in the Excel solver. Specifically, I'm going to discuss or introduce to you the use of linear programming. To help businesses deal with a shortage of workers, labor planning is a schedule which is developer set. It is an act of balancing in a process to make sure that the persons with appropriate skills are where they are needed at the moment, ensuring they have all the necessary skills and abilities. This will also help reduce the overall cost for the organization. Many banks employ the LP method, which is used for handling labor scheduling. The Hong Kong Bank, for example. Tellers at the Hong Kong Bank of Commerce and Industry are hired according to the hours of the day. To keep labor expenses down, the bank allocated tellers to positions at a certain time of day. Even though it has a 12-person staff, many workers are still on the bank's part-time roster. A part-time employee is expected to be present for at least 4 hours per day, but can begin as early as 9 a.m. and as late as 1 p.m. Part-time workers have a reasonably low cost to the company since they do not receive retirement or lunch benefits. Full-time workers are granted an hour for lunch and are on the job from 9 a.m. to 5 p.m. At 11 a.m., half of the full-time workers eats while the other half works. Full-time workers contribute 35 hours of productive time per week. The bank implements a policy through which part-time work hours are limited to the maximum of 50% of the total required work hours per day. On the average, part-time workers make $8 per hour or $32 per day. Full-time employees receive an average of $100 a day in compensation and benefits. To minimize total labor costs, the bank wants to implement a scheduling method that can be implemented on a regular basis. When it's in the interest of the company to do so, like profitable, it will release some of its full-time tellers. The table shows the number of personnel that the bank needs in the various periods of the day when it is open. It's most obvious that during lunch between 12 and 2 p.m. is the busiest time of the day. A limitation is enforced every hour of the day, and it states that at least the minimum number of employees are required during that time. Therefore, there are 8 of these constraints, which are from 9 a.m. to 5 p.m. We will also impose a restriction on the overall number of full-time workers, and this cap will be 12. The last constraint will specify the number of part-time hours that should not exceed 50% of the total hours. Here are the variables na magagamit natin to achieve the goal or objective, which is to minimize cost of daily personnel. Let F as the full-time tellers, P sub 1 as a part-timer starting at 9 a.m., P sub 2 as part-timer starting at 10 a.m., P sub 3 as part-timer starting at 11 a.m., P sub 4 as part-timer starting at noon, and P sub 5 as part-timers starting at 1 p.m. The objective is to minimize the total daily personnel costs, and to get this, the salary of full-time and part-time workers will be added and multiplied. These constraints are scheduled of how many personnel, either full-time workers or part-time workers, should work within an hour. There are 2 optimal schedules for Hong Kong Bank to follow, but as for this scenario, we will use the first schedule as an example. Here is the example solution in Excel for labor planning schedule. As what I have said kanina na ang variables, ito yung mga workers or personnel which work full-time and part-time. Then, yung values, ito naman yung isa sa mga optimal schedules used, which is given by using the Excel solver. The cost or the salary of the workers for a day, $100 for the full-time, then $32 for those who work part-time. The number 1 means that all workers work at that time of the day. Ibig sabihin naman ng 0.5 is that only half of the workers work at a particular time while the other half are having their lunch. The computation using the Excel solver are shown from the previous reporter. Though it was a different example, yet the process of how did we ended up with the amount of values, LHS, and the objective or the total cost is the same. The next topic will be about the financial applications, and under these are the portfolio selection and the truck loading problem. But first, let us discuss about the portfolio selection. Portfolio selection is a process by which one chooses the securities, derivatives, and other assets to include in a portfolio. In making security selections, one considers the risk, the return, the ethical implications, and other factors affecting both of the individual securities and the portfolio as a whole. Sa portfolio selection, ang kanyang objective is to maximize the potential return on investment from a variety of alternatives. For example, the International City Trust. Gusto niya mag-invest sa 4 na different fields which are the trade credit, corporate bonds, gold stocks, and construction loans. The table shows how much each field has its rate of return. 7% for the trade credit, 11% for the corporate bonds, 19% for the gold stocks, and 15% for the construction loans. The ICT wants to accomplish 2 things by investing $5 million. First is to maximize the return on investment for the next 6 months, and then satisfy diversification requirements set by the board. Diversification is a process which it allocates its capital or invests it from the different fields to reduce risk. Moreover, the funds invested in gold stocks and construction loans should be at least 55% or higher its total budget. In addition, no less than 15% of the budget should be invested in trade credit. However, the ICT only has a $5 million budget, and the company set a maximum investment for each field based from the table shown previously. Yet, the company wants to maximize the return on investment with these investment conditions. Here are the variables that will be used, which are X sub 1 as the dollars invested in trade credit, X sub 2 as the dollars invested in corporate bonds, X sub 3 as the dollars invested in gold stocks, and X sub 4 as the dollars invested in construction loans. The objective of ICT is to minimize dollars of interest earned with the help of the equation, which is interest from the different fields multiplied to invested capital and by adding its product. Here are the constraints that will be used in solving the equation by using the Excel solver. The optimal solution to the ICT is to make the following investments. The X sub 1, they will invest an amount of $750,000. For the X sub 2, an amount of $950,000. For the X sub 3, an amount of $1.5 million. And for the X sub 4, an amount of $1.8 million. The total interest earned with this plan is $712,000. In this table, the total cost, LHS, and the solution will be given by using the Excel solver. The max return is from the objectives, and the RHS is from the constraint, which the variables or the problem is subject to. The truck loading problem involves deciding which items to load on a truck so as to maximize the value of a load shipped. The truck loading problem is about selecting the item which is most profitable that you can transport on a truck. Since the truck has a limit of how much items should be loaded based from its weight, truck hauling loads exceeding gross vehicle weight ratings can lead to equipment and brake failures, as well as increased stopping distances. The table below shows the items which needs to be shipped by the Goodman Shipping with its value and weight. The goal of this problem is to maximize the value load in the truck without exceeding the truck's weight, but also minimizing the load or items in a truck which should be less than or equal to 10,000 pounds. The decision variable is the X sub I, or the proportion of each item loaded on the truck. This slide shows the generated answer or solution by using the Excel solver. The table shows how much the total value should be shipped, which is $31,500. The Goodman shipping problem raises an interesting issue. The solution calls for 1/3 of item 1 to be loaded on a truck. Rounding down leaves unused capacity on a truck and results in a value of $24,000. Rounding up is not possible since this would exceed the capacity of the truck. Using integer programming, in which a solution is required to contain only integers, the solution is to load 1 unit of items 3, 4, and 6 for a value of $27,250. And this ends my report about the employee scheduling applications and financial applications.
So, good morning everyone. Our next topic is about the ingredient blending application. And under this application, we have two topics, the diet problem and the ingredient mix and blending problems. So first, let's talk about the diet problem. So diet problem is one of the earliest applications of linear programming, and it was originally used by hospitals to determine the most economical diet for their patients. It is known in the agricultural applications as the feed mix problem. The diet problem involves specifying a food or feed ingredient combination that satisfy the stated nutritional requirements at a minimum cost level. So, the goal of the diet problem is to select a set of food that will satisfy a set of daily nutritional requirement at a minimum cost. The problem is formulated as a linear program where the objective is to minimize the cost and the constraints are to satisfy the specified nutritional requirements. So for this application, let's use the Whole Food Nutrition Center as our example. So the Whole Food Nutrition Center uses 3 bulk of grain to blend a natural cereal. It advertises that the cereal meets the U.S. recommended daily allowance for the 4 key nutrients. It wants to select a blend that will meet the requirements at the minimum cost. So the table below shows the 4 key nutrients their cereal contains, and these are protein, riboflavin, phosphorus, and magnesium. The other column of the table shows the amount of nutrients recommended by the USRDA for each 2-ounce serving of their cereal. In modeling this as a linear program, the objective is to minimize the cost. There will be 4 constraints, 1 each for protein, riboflavin, phosphorus, and magnesium, showing the number of units for the minimum amount specified. Since these requirements are for each 2-ounce serving, the last constraint must say that the total amount of the grains used will be 0.125 pounds. In order to calculate the total cost, we must know the number of pounds of the grains used in 1 serving of the cereal. Also, the numbers in the table below are expressed in units per pound of grains, so defining the variables as a number of pounds of the grains makes it easier to calculate the amounts of protein, riboflavin, phosphorus, and magnesium. For the variable, we let x sub A be pounds of grain A in 1 2-ounce serving of cereal, x sub B be pounds of grain B in 1 2-ounce serving of cereal, and x sub C be pounds of grain C in 1 2-ounce of serving of cereal. The objective for this example is to minimize the cost of mixing a 2-ounce serving, which is equal to the sum of $0.33 x sub A plus $0.47 x sub B plus $0.38 x sub C, which is subject to the constraints below. And as I've mentioned earlier, we have constraints for each of the nutrient, and the last constraint is about the total amount of grains used. The picture illustrates the solution for the example using the Excel solver. It shows the variable, which are the x sub A, x sub B, and x sub C, that represents the pound of grain A, grain B, and grain C. The objective, the constraint, and the LHS and the RHS. The solution for this requires mixing together 0.025 pounds of grain A, 0.050 pounds of grain B, and 0.050 pounds of grain C. And the total cost per serving is equals to $0.05. So our second topic under the ingredient blending application is the ingredient mix and blending problems. So diet and feed mix problem are subsets of a broader class of linear programming issues, referred to as ingredient or blending problems. Blending problems arises when a choice must be made between two or more resources in order to produce one or more products. So in this situation, resources contain one or more essential ingredients that must be mixed in such a way that each final product contains a precise portion of each ingredient. So sa ingredient mix and blending problem is about just a mixing of important ingredients para maka-form ng final product. Tapos, the product contains a specified amount of each ingredient. So our example for this problem deals with an application of linear programming in the petroleum industry, the blending of crude oils to produce refinable gasoline. So the Low-NAC Oil Company produces two grades of cut-rate gasoline for industrial distribution. The two grades, regular and economy, are created by blending two different types of crude oil. The crude oil differs in the cost and its content of crucial ingredients. And the table below indicates the two types of crude oil, the percentage of crucial ingredients found in each crude oils, and the cost per barrel for each. Weekly demand for the regular grade of low-NAC gasoline is at least 25,000 barrels, and the demand for the economy is at least 32,000 barrels per week. At least 45% of each barrel of regular must be ingredient A, and at most 50% of each barrel of economy should contain ingredient B. The Low-NAC management must decide how many barrels of each type of crude oil to buy each week for blending to satisfy demand at a minimum cost. In modeling this as a linear program, the objective is to minimize the cost. Each of the two types of gasoline has a demand constraint, and each of the two types of gasoline has a constraint restricting the amount of the ingredients. Thus, there are four constraints. The decisions involve the amount of each type of crude to use in each type of gasoline. So this will be the decision variables. Let x sub 1 be the barrels of crude X100 blended to produce the refined regular, x sub 2 be the barrels of crude X100 blended to produce the refined economy, x sub 3 be the barrels of crude X220 blended to produce the refined regular, x sub 4 be the barrels of crude X220 blended to produce the refined economy. So this slide shows the computation of ingredient A in the regular constraint. And this slide shows the computation of ingredient B into economy constraint. The objective of this problem is to minimize the cost that is equals to the sum of $30 x sub 1 plus $30 x sub 2 plus $34.80 x sub 3 plus $34.80 x sub 4 and it is subject to the following constraints. Using the Excel, the solution to low NOx oils formulation was found to be X sub 1 is equal to 15,000 barrels of X100 into regular, X sub 2 is equals to 26,666.67 barrels of X100 into economy, X sub 3 is equals to 10,000 barrels of X220 into regular, and X sub 4 is equals to 5,333.33 barrels of X220 into economy. And the cost of this mix is $1,783,600. So, the last topic for our report is about the transportation applications. And under this application is the shipping problem. So, transporting goods from several origins to several destinations efficiently is called the transportation problem. And the transportation or shipping problems entails determining the quantity of products or items to be delivered between many origins or sources. Typically, the purpose of this is to reduce total shipping costs or distances. Constraints in this type of problem is concerned with the capacity of each origin and the requirement of each destination. Transportation is a highly specific instance of linear programming. Transportation problem is a special kind of linear programming problem in which the goods are transported from a set of sources to a set of destinations subject to the supply and demand of the sources and destinations respectively, such that the total cost of transportation is minimized. So let's use the Top Speed Bicycle Corporation as our example in this application. So the Top Speed Bicycle Corporation manufactures and markets a line of 10 speed bicycles. The firm has a final assembly plants in 2 cities where labor costs are low. It has 3 major warehouses near large markets. The sales requirements for the next year are 10,000 bicycles in New York, 8,000 bicycles in Chicago, and 15,000 bicycles in Los Angeles. The factory capacities are 20,000 bicycles in New Orleans and 15,000 bicycles in Omaha. The cost of shipping bicycles from the plants to the warehouses is different for each plant and warehouses, and it is shown in the table below. The company also wants to develop a shipping schedule that will minimize its total annual cost. In this slide, the picture provides a network representation for this problem. Each circle represents source or a destination in this problem. Each source and destination is numbered to facilitate a variable definition. Each arrow indicates a possible shipping route and the cost per unit to ship along each of these. It also shows the demand and the supply of the bicycles. The double subscript variables will represent the origin factory and the destination warehouse. And it is X sub I and J, where bicycles ship from factory I to warehouse J, where I is 1 and 2, where 1 is New Orleans and 2 is Omaha. And J is 1, 2, and 3, where 1 is New York, 2 is Chicago, and 3 is Los Angeles. And the variables are shown below. When formulating a linear program for this, the objective is to minimize the transportation cost. There are 2 supply constraints, 1 for each sources. 1 is no more than 20,000 can be shipped from New Orleans. 2 is no more than 15,000 can be shipped from Omaha. There are 3 demand constraints, 1 for each destination. 1 is the total number of shipped to New York must equal to 10,000. 2 is the total number shipped to Chicago must equal 8,000. And 3, the total number shipped to Los Angeles must equal to 15,000. The company must decide how many bicycles to ship along each of the shipping routes. Using the Excel solver, the computer-generated solution to the top speeds problem is shown in the picture, and the total shipping cost is $96,000. In this slide, the table shows the solution for this problem. Transportation problems are a special case of linear programming, as the coefficients for every variable in the constraint equation is equal to 1.